So looking back at that example we studied in section 6.1, where by finding the asymptotes by hand we found asymptotes at 3 and 1, but by doing it on the graphing calculator we only found an asymptote at 3. If we deal with this in a different manner, and instead of just solving for the bottom, we actually factor out the top and the bottom, meaning we would have on the top we need two numbers that multiply to 2 and add to negative 3, so x minus 2 and x minus 1. On the bottom we would factor to x minus 3 and x minus 1. We had the asymptote at 3 because of that x minus 3, but now with the x plus 1, because we have that factor on the top as well, that complicates things. This doesn't lead to an asymptote, this leads to what's called a hole in the graph. Now a hole in the graph is exactly what you would expect it to be by looking at it. If we draw out that function, that would be a continuous function because I could draw it in one pen stroke. But if that graph had a hole in it, I'd have to stop, lift the pen, draw a small hole, and continue on. That function is discontinuous at the hole because I had to actually physically lift the pen. Now when we graphed that on the calculator, that hole was much too small to be seen. That's why we didn't notice it. So we would have thought that the function was continuous, even though it actually wasn't.